You'll definitely need a periodic table. Like, you need a periodic table for the rest of the year. Which I do have a few somewhere. I might need to print some more off. Let me check my online students here real quick because they're all popping on. Now I have people that missed the test from, if I say last Friday, I mean like the last school Friday. And I'll go back over that in just a bit. Slate. I can't remember if anybody in chemistry was trying to email me. I didn't even check my email until Friday morning. And I had some people that were like, I swear I turned this in. I swear I turned this in. And then when I checked on Canvas, no, you didn't. There's 0 submission. This is going to take me a minute to do my remote. You can't hear anything. You should be able to hear. I can see my little voice bar thing going. Make sure you have your sound on. Make sure you don't have headphones plugged in. What else would your Chromebook not be making noise? That's normally one of those two things. But she shouldn't. Normally it's one of those two things because I can see it going. Now, let me know if you figure it out. Worst comes to worst, you could try. Well, she can't hear me. What am I talking to her? Here. I just realized she can't hear me. I'm talking to her. Oh. Okay. Let's see if I can get her working here. Let me get all this thing going too. All right, so I've got to go back and double check all my students that are remote. We're having more contact tracing and quarantines and stuff going crazy. But I have been waiting for this part. You definitely need a periodic table. And I'm going to start calling on people, making sure that you know how to read this thing. Because we are, let's see, this one's remote. We're starting up what we're doing. You have to be able to write formulas the rest of the year. And that's what we're starting with, is we're starting with just ions. Easy stuff, just ions. There's a few things that are in Canvas. One of which is this polyatomic ion chart, which if you want a paper copy, you need a paper copy. You have to start memorizing these guys. Okay, we will have a quiz on Friday over group 1 and 2. These are all -1s. There's what, 9 of them? 9. And I'll pass these out for those of you that just have to have a paper copy in a minute. But it's in Canvas. We're going to start with naming ions. And we've been talking about them, talking about these elements and these valence electrons, and they either have positive charges or they have negative charges. So for this opener, which is in Canvas, we're going to figure out with the ones that are listed, if it's a group A element or group B. Then we're going to figure out where the metals versus the non-metals are on the periodic table, which is what PT is short for. First of all, copper. Copper is Cu. So you need to find copper. You tell me, is that a group A or a group B element? What type of metal is copper? If you have your color-coded periodic table. You guys not have them anymore. Okay, this section, Sebastian, wake up. This section in the middle, these transition metals, these are all group B elements. And the thing that makes these a little bit more difficult is there's more than one type. Now you should have put a +1 in silver's box, and then a +2 in cadmium and zinc's box right next to it, over here on the side. Those are the only 3 that do not have to tell you their charge, because they only have 1 charge. All the other guys here in the middle, they're a raw pain in the butt. We need to be able to do Roman numerals to tell their charge. And if you do not know your Roman numerals, I will go back over it. That's something that, I mean, Everything is digital now. You probably haven't even seen a clock that uses Roman numerals. They just use regular numbers. So it's okay if you don't know how to read them. If they're not difficult, I'll show you how to do it. So copper, this is a group B. Silver, which is right underneath it. Is that a group A or a group B element? It's the same as copper. What is copper? Group A or group B? Group A. Sodium, Na, way over here. Is that a group A or a group B element? That's a group A. Remember, groups 1, 2, then you skip this part, 3, 4, 5, 6, 7, and 8. Those are your A elements. It's these guys in the middle. These guys are inner transitions. They're all messed up. But these guys in the middle, these are your group Bs. What about lead? Lead is Pb, which is right here. Is that a group A or a group B element? No. That's an A. That's in group 4A. It's in carbon's group. And then potassium, which is the letter K, not the letter P. P is phosphorus. Potassium is K. It's in group 1A. Those are your alkali metals. I know the one that I gave you didn't put the Roman numerals up on the top. We put the charges, the oxidation charges up on the top. I've used different periodic tables for the colored ones, and I may go back to my old one. It just puts two elements in the wrong spot. But that's okay. So where are the metals on the periodic table? How do you know where metals are? Where are they located up there? Whoa, you guys slept way too much over Thanksgiving. This thing right here, it's red. Where are metals in relationship to that staircase? The left of the staircase, hydrogen is a nonmetal. Where are the nonmetals? They're to the right of the staircase. Metals tend to be positive cations, and nonmetals tend to be negative anions. The cations want to lose their electrons, and the anions want to gain electrons. Yes, hydrogen is a little weird. The nonmetal that actually loses its electron instead of gaining them. So that was sort of like a wrap up, because I know you guys weren't doing chemistry every break. I don't blame you. That was sort of a recap of what we were doing before the break. I lost my cursor. And it's not, oh, it's because it's on. It's on laser. Where'd you go? Oh, there it is. All right, who needs a paper set? Who needs one of those? Okay. I added stuff to this that I think will help you also with a paper set. It's not a lot that I added to what you do a paper one that the other chemistry teachers do here, but I think it'll help putting these rules down. Yes, check. And then we all want to do it. And I'm assuming you do a little color on top. This is what COVID behaves itself, even though it's teaching all them better. Do you want me to read it? Yes. So that happens. I don't know what it is. I really. Ooh, one of our science teachers went out and told them. We give you guys also a copy of the polygon ion chart. And I did two typos on this that I caught, and I fixed them. I don't know how long Abel's list had the wrong sulfite and sulfate on it, but I fixed it for you. It's fixed on Canvas. You need to start memorizing that. And hopefully we'll have enough time that I can give you a couple of tips on how to do this. Some of you might need flashcard learners. That's fine. I don't have any flashcards to give you. But once again, it is group 1 and 2. That's 1 and 2. You start taking a look at it. They're just matching like normal in Canvas quiz. Right. So we are. What the heck just happened? That was weird. Okay, we are going to start with just ions. Oh, I am shocking myself. Every time I touch my tabletop, I'm shocking myself today. We are going to start specifically with ionic compounds. So you have positive ions, okay, which are metals, and yes, hydrogen's weird. And you have negative ions, which are normally nonmetals. And you should have put what we call oxidation charges across the top. So the above group 1 was +1, above group 2 was +2, skip over to 3, +3. Then it was +-4, then it was -3, -2, -1, and 0. With metals, you do not change their name. Okay, so it's potassium is just potassium, and aluminum is just aluminum, calcium is just calcium. If it's group 1 and 2, you don't do anything special. Now, group 3A, aluminum does not need a Roman numeral, but the other metals in 3, 4, 5A, they have different charges. And we use Roman numerals to say what the charge is. You just may need to learn how to write in Roman numerals. So the exceptions, and I think a lot of this is on yours. Yes, because I changed some of these. I don't remember what I did change from there and what I did not change. Because there's more than one type. But like I said, there's a couple of things that I did add on here that you guys do not have. So exceptions, silver is in group 3, but it's a group B, but it's always +1. Cadmium and zinc are always +2. Those are the ones that are inside here that I told you to write their oxidation charge in their box. They don't get a Roman numeral. Aluminum is the only one that's on this side, that is a metal, that does not get a Roman numeral. All the other ones have to have one. I don't know what happens with a copier. It's sort of like crumpled up the papers. It came out that way. So metals are to the left of the staircase. Yes, hydrogen is a nonmetal, but it's still going to lose its electron to get a +1 charge. What am I hearing? What is tinkling? All right, Roman numeral review. You may not be familiar with these, but the letter I, a capital, that's not an L, a capital I means 1 in Roman. If there's more than one I, you just add them. So I is 1, I is 2, I is 3, you literally add them. The way that we do 5 in Roman is a V. This is how they do the numbers on the Super Bowl, by the way. Like that's where those come from, the Roman numerals. The Roman numeral 10 is X. So literally 1 and 1 is 2, 1 and 1 and 1 is 3. Now, IV is 1 before 5, which is 4. The 4 is one number before 5. If you see an I after the V, then you add it to it. So 5 plus 1 is 6. This one over here, because you can't see me pointing. 5 plus 1 is 7. 5 plus 3 more is 8. This is 1 before 10, which is 9, and then 10. So you have to know how to read Roman numerals. We normally do not go past 4. It does happen sometimes. We normally do not go past 4. And a Roman numeral tells you whatever that is how positive, which is how many electrons it's going to lose. That's how positive the ion's going to be. You only have to use Roman numerals with those group Bs and then the metals to the right of them except for aluminum. Otherwise, they don't need it. Ionics are way harder because there's so many little things that you have to know in what we call nomenclature, naming them and writing formulas, that you just don't have to deal with molecular. Y'all are going to probably like molecular a whole heck of a lot more because they're simpler. And I don't think you guys are going to have a test until I don't think you're going to have one until the 15th on this. Lots and lots and lots of practice days with this stuff. Negative ions, their endings change. Okay, positive ions, they don't. They might get a Roman numeral, but you don't change their ending. It's copper is still copper, but you need to tell me if it's copper 1 or copper 2. Iron is still iron, but I need to know if it's iron 2 or iron 3. Lead is still lead. I just need to know, is it lead 2 or is it lead 4? Because there's different types of that element. The second thing that's listed, your anion, you need to make sure it ends in I. If it's an ene element, chlorine, bromine, iodine, astatine, you just change INE to IDE. There's nothing to it. However, there are some that do not end in INE, and those are the ones that irritate the snot out of me when you don't spell them right. So, easy ones, if they end in ene, I'm sorry if you're colorblind and you can't see, but that's purple, okay, but INE literally changes to IDE, so it's not a chlorine ion, it's the chloride ion. It's not a bromine ion, it's a bromide ion. It's a sulfide ion. It's a nitride ion. So the ones that don't end in ene, oxygen, nitrogen, sulfur, hydrogen, and phosphorus. The part that I highlighted in blue is the part that gets changed out. Now, I don't know why it irritates me so much. Do not write oxide. It's oxide. You keep, most of them, you keep the first syllable, and then you change all the rest of the word to I. With the exception of, well, you do it in every single one. You keep the first syllable, oxygen, ox, nitrogen, nit, hydrogen, hyd, sulfur, sulf, and phosphorus, phos. It keeps the first syllable and changes everything else to IDE. But other than that, you literally change INE to IDE. And then it's an ion. And we're doing both. We're doing both writing formulas and naming today. We're not making compounds yet. We're just naming and writing formulas for ions. Okay. If there's 2 or more elements in the ion, it comes off that chart, which I don't have one in my hand. For those of you that are online, there's a link to it in Canvas. It says Unit 5 notes, naming and writing chemical formulas. Is this to color it? I'm not going to ask you to color it. But group 1 and group 2 are the ones that there will be a quiz on Friday. These are all -1 ions. I personally write -1. Okay, if it has just a negative sign, it's understood that there's 1. But I was taught to write the 1 as a charge. But these things, all of them are negative except for one of them. There's only one positive polyatomic ion, which is ammonium. Where is it at? Right here. The ammonium is the only positive ion. And most of them end in the endings 8 or 8. Not all of them, most of them do. So if you are making a formula and you see 8 or 8, you need to take a look at this list. I asked the other chemistry teachers, do we let you guys use an ion list? And they said, no, you guys have to know these. Eventually, we're going to talk about acids and bases way down the line. And there's this whole weird naming system to figure out, is it hydrochloric acid? Is it chlorous acid? Is it chloric acid? Is it perchloric acid? Is it hypochlorous acid? There's 4 major types. No, 5 major types. And it has to do with how many oxygens are present. If you look at an 8 or an 8, and it has the same parent element, so with the ones I just rattled off is chlorine, the thing that's not oxygen. If you're just looking at an 8 and 8, the 8 has 1 more oxygen than its 8. It's like it ate the 8's oxygen, like it ate it. It has 1 more. That's all it means is 1 more. Doesn't mean 2, doesn't mean 3, it just means more. 8 means 1 less. And most of them, if there is an 8 and 8, that's it. They're like sulfite, sulfate, nitrite, nitrate. Phosphite, phosphate. Which one am I forgetting? I'm forgetting some. They don't all have two. So the ones that don't end in I or E, cyanide, carbon and a nitrogen. Like I said, I write the one with the charge. You don't necessarily have to, but if you don't write a number, that means by one. Ammonium's positive one, NH4. It is a nitrogen that is stuck to 4 hydrogens. And then hydroxide, which is a hydrogen and an oxygen that carries a -1 charge. And then I can't remember if I put this on the paper or not. Did I put these on yours? I did. You probably want to write down there the formula for cyanide, ammonium, and hydroxide. We don't use cyanide very much, but we do use ammonium and hydroxide all the dang time. This is what makes a base a base. This thing wants to suck up a hydrogen and make water. Now, I have these guys here. Without cheating and looking on your chart, which is right in front of your face, 8s have more oxygens than ites. Which one is phosphite with an I? The one on the left or the one on the right? Does ite mean more or less? ITE. Less. So which is phosphite? The right one. The one on the left is phosphate. They both carry a -3 charge. Now, 8 does not mean 4. 8 means more. 8 means less. And I did that, and I went ahead and have some that have 4 and 3 again. Which is sulfate and which is sulfite? Look, sulfate is the one on the left. It has more oxygens. They both carry a -2 charge. And then I don't think I put, I don't know why this didn't put all these creases in here. On yours, because I'm pretty sure I didn't put it on the board, you have NO3 -1 and NO2 -1. They are named after nitrogen. So which is which? One is an 8 and one is an I. Which is which on your paper? Because this one is not up on the board. So on your paper, you have NO3 -1 and you have NO2 -1. They're both named after nitrogen. So one is nitrite and one is nitrate, which is which? The 8 one is on the left. The I one is on the right. These polyatomic ions, with a few exceptions, they are named after the thing that is not oxygen. Carbonate is named after the carbon. Chromate is named after the chromium ion. What else is on there? The ones with chlorine are named after the chlorine ion. Dichromate has 2 chromiums. Acetate's a little different. That's one of the ones you need to know for Friday. That is the fancy name for vinegar. Vinegar is acetic acid. That's what's in it. And lets you take the shell off of an egg. It makes it a really liquid water balloon. All right, so example time. On the back, we have a few of these that we're going to name. What is the name of that? Comes from bromine. What is the name of its ion? What did I say you change I-N-E to? I. So bromine becomes bromide. Then it's an ion. The only way that you've written ions before, and I'm sorry for those of you, and I don't have a black expo because they use them. The only way that you've written an ion before is this one. This one's out too. That's how you've written ions before. We're actually naming them now. Okay, what about this one? That's magnesium. Magnesium. What is its ion going to be? Do you change its ending if it's a positive ion? No. So what is the name of its ion? The magnesium ion. Yet you only change the endings of the nonmetals, which in most cases, hydrogen's weird, y'all. Hydrogen can act so strange. Normally it's the things to the right of the staircase that are going to change the ending to I, that are not metals, because there are some metals that are to the right of the staircase. A phosphorus. I'm highlighting what's changing. What's it going to be called? Not phosphoride. The ORUS is all changed. That's phosphide. I said most of them seriously, they follow this rule. This part gets replaced. There's a few of them that are a little weird. That was oxygen, sulfur, nitrogen, phosphorus, and hydrogen. Iron. Are you going to change its ending? No. But I need to know what its charge is. So how do you write 3 in Roman numerals? 3 I's. That is how you write the ion 3 ion. There are so many, but you have to remember to do this. If you have a transition metal, if you have a metal that is outside of group 1 or 2A, with 4 exceptions, you have to tell me the positive charge. What are a plus in there? What's the numerical value for that charge? I is 1 plus 1 plus 1, which is 3. Lead. Lead needs a Roman numeral. How do you write 4? And, well, it's an I, but yeah, an I and a V, and that is its ion. I do have the one, got a few more. Okay, I know it's a bunch of, you gotta remember to do this. Is there a question how I got these 2 Roman numerals? Yes, you have to know how to do 1 through 10. We normally don't go past 4. Every now and then I've seen a 6, but that's not common. All right, so silver. Silver does not need a Roman numeral because it's one of the ones that you put its charge in its box. So do you need to change the ending if it's a positive ion? No, and it does not need a Roman numeral. Silver is always positive 1. This and this is a polyatomic ion. They're not named for the oxygen. They're named for the thing that's not oxygen. So this is named for sulfur. Is this going to be an 8 or an I? It's an 8. So for right now, you're going to have to look at the chart. This is not one that you're memorizing in the first section. This is a sulfate ion. If it was SO3, it would have been a sulfite ion. It's named for the hydrogen. This is just, it's hydroxide. We use this all the time. That is the hydroxide ion. It is a hydrogen. They can't see my laser. It is a hydrogen that is bonded to an oxygen. And it has formed an ion. That is what that is named for. You end up taking biochemistry in college or organic chemistry in college. When we write water, we don't write it H2O, even though that's the formula. We write it this way. That is how you write water. Because when it breaks apart, this is how it breaks. That is how it splits apart. Water is neutral because it's exactly 1/2 acid and 1/2 base. Makes it neutral. Don't worry, we're not going to learn organic chemistry. I have fun if y'all take that in college. Treat it like a foreign language. That is my best advice I can ever give somebody going into organic. I didn't understand organic until I took biochem. Organic is learning the alphabet. Biochemistry is learning how to make sentences. It's different. All right, we have ions. What is strontium's symbol? You have to take a second and find it under periodic table. I can tell you it's a metal because it hasn't changed the ending. It's SR. It's in group 2. So what is its charge? +2. Hopefully you have this. It has the charges up on the top. Copper symbol is Cu. There are 2 types of copper. What is the charge of this copper? Plus how much? What does this number mean? 2. There's 2 types of copper. There's copper 1, which is +1, and there's copper 2, which is +2. Carbonate. You ain't gonna have to come look over here. Find the carbon attached to the oxygen. The 1 carbon attached to the oxygen. And what is its formula? It's in the -2 group. 1 carbon, how many oxygens? 3, and it carries a -2 charge. And then the ammonium ion, once the heater kicks in, it gets warm, but it takes forever to kick in. Ammonium is down here. This is the only positive polyatomic ion on the entire chart. I think that's the last slide. And then we do have an assignment that goes along with this. And I know most of you want paper copies. And we have, I really tried to like build this as a Canvas quiz, and I ran out of time. So instead of doing that, I went ahead and printed it off. So, I mean, you can do them online and upload them. And we have 15 minutes. Who needs a new periodic table? I need to run more off. I don't know if I have enough to give to everybody. Who else needs a new periodic table? You do? What do you put? You need a periodic table, okay. You know me? Well, this is the assignment. Are you going to do it online? You're going to do it online. Let me see how many I have. I'm not going to give you the one that we color coded. I'm going to give you an older one. Who else did they need to figure out the Now, some of them were done for you. The iodine, capital I, iodine, iodine, I've heard it pronounced both ways. So, once again, INE, if you get one of those, chlorine, fluorine, iodine, bromine, aspartame, those are all the E ones. You just immediately change that ending to IDE. If you see, oh, those were not created in as superscripts. Okay, well, I'm going to fix it for the Google. Oh, goodness. Here, let me show you what I see wrong on your paper, although